Now the Z chart, which is actually popularly known as the Smith chart. So for this, we will start with this expression Z is equal to Z means impedance. Impedance is equal to Z0. Z0 is the characteristic impedance into 1 plus gamma Z by 1 minus gamma Z. Gamma is the reflection coefficient. Now what we will do is we will define a normalized impedance. Normalized impedance is the impedance normalized with respect to the characteristics impedance. Normalization, by normalization what we do is we divide that. So here we divide the impedance with characteristics impedance. So impedance normalized with respect to characteristics impedance means the impedance divided by the characteristics impedance. So define the normalized impedance Zn. So Zn is equal to the impedance Z divided by characteristics impedance Z0. So now that will be equal to 1 plus gamma by 1 minus gamma. Now you know that impedance itself is a complex number. In general, impedance is a complex number. And when you divide the complex number by a real number, Z0 will assume to be real number. So when we divide a complex number by a real number, we get a complex number. Therefore, Zn has to be a complex number. So let us write Zn is equal to Rn plus Jxn. As we know, Z is equal to R plus Jx, impedance is equal to resistance plus Z times reactance. So Zn will be Rn plus Jxn. So that part there is no ambiguity. Now Zn is equal to 1 plus gamma by 1 minus gamma. Therefore, Rn plus Jxn is equal to 1 plus gamma by 1 minus gamma. Now gamma is, we know gamma is equal to gamma R plus J gamma I. So put that. So Rn plus Jxn is equal to 1 plus gamma R plus J gamma I divided by 1 minus gamma R plus J gamma I. So that will give us in the numerator 1 plus gamma R plus J gamma I, in the denominator 1 minus gamma R minus J gamma I. Now what we will do is multiply both the sides, the left hand side and right hand side, by the denominator of the right hand side. If we multiply both the sides by denominator of right hand side, then on both the sides we will have no denominator, or denominator will become 1. So left hand side will be Rn plus Jxn whole into 1 minus gamma R plus then minus J gamma I. That will be the left hand side. Right hand side will be 1 cross gamma R then cross J gamma I. Now what we have to do is equate the real part and imaginary part. We have two sides, left side and right side. Both sides are complex. Now equate the real part. If there are two complex numbers are equal, then their real parts are equal and their complex parts are equal. Therefore, we equate the real parts and imaginary parts. When we equate the real part and imaginary part, then we will solve the resulting equations for the real part and the imaginary part for gamma R gamma I in terms of Xn, in terms of Rn and Xn. So first equate them, then solve the resulting equations for gamma R and gamma I in terms of Rn and Xn. This will give us two equations. The first equation is gamma R minus Rn by 1 plus Rn square whole square plus gamma I square is equal to 1 by 1 plus Rn whole square. Now if you look at this equation, this is the equation of a circle which has a center at Rn by 1 plus Rn and 0 and whose radius is 1 by 1 plus Rn. Now what does this imply? It implies that as we vary Rn, the circle, this is actually a family of circle. As you vary Rn, you will get different values of different circles. They will generate different circles. And just now we have seen that the limit on the gamma is absolute gamma is less than equal to 1 and Rn has to be less than equal to 0. Since Rn has to be less than equal to 0, the smallest value of Rn has to be greater than equal to 0. Since Rn has to be greater than equal to 0, the smallest value of Rn will be equal to 0. Smallest value of Rn is equal to 0 means if I put that smallest value of Rn is equal to 0, let us put Rn is equal to 0, that is the smallest value. If we put that value, then Rn by 1 plus Rn, that is 0. 0 by 1 plus 0, that will be 0. So 0, 0. That is the center of the circle. Circle center will be 0, 0. When Rn is equal to 0, center of the circle will be at the origin. On the gamma plane, center of the circle will be on the origin. Radius of the circle will be 1. So it will be a unit circle. Unit circle means a circle with radius 1. So it will be a unit circle with its origin at the center. Now then next, what we can infer from this? Rn is equal to 0 means resistance is equal to 0. When resistance is equal to 0, that implies a short circuit or open circuit. It implies always a short circuit. So that is what we are going to get. We are going to get a short circuit because of that. So when we have a short circuit, that gives us a circle on the gamma plane, that gives us a circle whose radius is equal to 1, whose center is at the center of the gamma plane. All other circles, as you keep on increasing Rn, all other circles will be embedded within this circle. So this short circuit, this circle will cross gamma r, the horizontal line gamma r, it will cross at 2 points, on the left hand side, on the right hand side. Left hand side actually represents the short circuit point. Right hand side will represent the open circuit point. Why it will represent the open circuit point? That will be clear if we consider Rn to be infinity. If Rn is equal to infinity, then the center will be Rn by 1 plus Rn, that is 1 by Rn plus 1. So that is 1 by 1, which is 1. So that will be 1, 0. So center of that circle will be, when Rn is equal to infinity, the center of the circle will be 1, 0. So from 0 you move in the right side direction, because it is 1, not minus 1. So it is 1. So move in the right hand towards the right to the point 1, and on the always the y-axis, for the y value it is 0, which means it is always on the x-axis or on the horizontal axis. So move by an amount of 1. 1 is the radius of the, for r is equal to 0. So you will move to the outermost point on the circle. On the large circle, you will move to the outermost point. So that outermost point on the right hand side represents Rn is equal to infinity. Rn is equal to infinity Rn is equal to infinity represents open circuit. Therefore, right hand side represents the open circuit. Ultimately, that indicates that the left hand side indicates the short circuit. So on the left hand side, extreme left is the short circuit, extreme right is the open circuit. On this horizontal line, in the gamma plane, on the gamma r axis, extreme left is the short circuit, extreme right is the open circuit. Radius, then we will consider radius. What will be radius? Radius will be infinity. So if we draw a circle with radius infinity, what will happen? If you draw a circle with radius infinity, the length of the any portion of the circle will be like a straight line. So that will be on the right hand side. So on that part we are not concerned, we are concerned with the point where the circle will be. So circle will be at that point on the right hand side with an infinity radius. Sorry, with 0 radius. Radius will be 1 by 1 plus Rn, which means Rn is infinity, means 1 by infinity, which is 0. So radius will be 0 and it will be on the rightmost point on the right hand side. The second equation from the imaginary part, we will get gamma r minus 1 square whole square plus gamma I minus 1 by xn whole square is equal to 1 upon xn whole square. This again is an equation for a family of circles with the center at 1 and 1 by xn, and radius is 1 by xn, absolute of 1 by xn. So this is an equation, this is for a family of circles. Now if what is xn? Xn is the reactive part. Reactive part can be of two types. It can be inductive or it can be capacitive. If it is inductive, then it is positive, xn will be positive. If it is capacitive, xn will be negative. So now look at the gamma plane. In the gamma plane, we draw these blue lines represent the portions of the circle that this equation represents. Why we are showing these small portions starting from the end, from the rightmost end we are showing the small circles. Reason is very simple. These portions of circle are shown because Rn is equal to 1 is the maximum value. Rn is equal to 0 is the maximum value for Rn. So anything that we do, so Rn is equal to 0 is the minimum value for Rn, and Rn is equal to infinity is the maximum value of the Rn. So that is represented within a region which is the outer circle, the black circle that we see. That circle represents all values of Rn from 0 to infinity. All values of Rn are within those range. So whatever xn we will see, those are also to be within that range, within those values, right? And so all impedances will have Rn from 0 to infinity. In between those two values, those are the extreme ends of the impedances. Therefore, everything will be within the circle that is represented through the black line. So the black circle represents all the circles. So xn will be confined to that region which is given by the black circle. And that is why xn is within that circle. Now xn, again the center of xn will be along the x is equal to 1 axis. X is equal to 1. Why it is starting from 1? The reason is x is equal to 1 is the rightmost point. X is equal to 0 is the leftmost point. X is equal to 1 is equal to is the rightmost point. So from the rightmost point, it will always be on the rightmost point. X value for the center of the circle is 1, which means x value is the rightmost point. So that point, that is the point from which it will start. Then when xn is positive, it will go in the upward direction. When it is in the negative, it will go in the downward direction, which means from the horizontal line you will go in the positive, which is in the above the horizontal line is positive, below the horizontal line is negative. Above the horizontal line is positive means the reactance of L, reactance of a inductor of an inductor is positive. So if it is positive, if you are above the horizontal line, then those lines, those circles, those portions of the circles, they represent the inductance. If you are below the horizontal line, then those portions of the circles will represent the capacitance, because Xc is equal to 1 by j omega c, which is equal to minus j by omega c. Therefore, negative values will represent the capacitive values or capacitive components, which will be on the which will be below the horizontal line, and positive values will indicate the inductive elements, which will be above the horizontal line. Now the circles, complete circles, are representing the resistance. The portions of the circles, these are representing the reactances. Positive reactances are above the horizontal line, negative reactances are below the horizontal line. When X is equal to 0, which means there is no reactance, it is purely resistance. When X is equal to 0, you can see that the center of the circle is 1, 1 by X or 1, 1 by Xn. Now Xn is equal to 0, which means it is 1, infinity. So the center will be at infinity and radius will be infinity. A circle whose y-axis center is at y infinity, x is equal to 1, at x is equal to 1 and y infinity, and radius is equal to infinity, that circle is actually a straight line. That is a straight line, which is the horizontal straight line. So in this horizontal straight line, if you have the horizontal straight line, that represents a portion of the circle whose radius is infinity. If radius is infinity, if you have a infinite circle or a circle of infinite radius, then a portion of the circle is a straight line. So this is a straight line. That is point 1. Then point 2 is its position is at x is equal to 1, center is at x is equal to 1 and y is equal to infinity. So this line represents a line on which we will have only resistance. This horizontal line is a line on which we will have only resistance, because we get this horizontal line when Xn is equal to 0 or reactance part is equal to 0. So this horizontal line represents a resistance, pure resistance. Outside this horizontal line, if you move upward in the horizontal line, then we can have resistance as well as reactance. If we move below this horizontal line, we can have resistance as well as reactance, and below this horizontal line is resistance as well as capacitance. The reactive part is capacitance. Above the horizontal line, it is resistance and inductance. Reactive part is inductance. Now as you come to the outer circle, outmost circle R is equal to 0, resistance is equal to 0. So on the outmost circle, it is only reactance. So if you look at the upper part from the horizontal line, if you look at the upper part of the outer circle, then upper half will represent the inductive values, lower half will represent the capacitive values. Now you can see on the second figure on the right hand side, that shows different x values. X is equal to 1 is meeting, put x is equal to 1, then the center will be at 1, 1, radius will be 1. So that is you can see what is x is equal to 1, what is x is equal to minus 1. Similarly, x is equal to x is less than 1 will be towards the left of that, x is greater than 1 will be towards the right of that. So 0 and less than xn, less than infinity is towards the right of xn is equal to 1, and 0 less than xn less than 1 is towards the left side of this vertical line, and xn is equal to 0 on the short circuit point, xn is equal to infinity on the open circuit point. Those also you can see. So we can see now we can see a portion of the Z chart or the Smith chart. If we see, this is drawn on the gamma plane, and you can see the leftmost point is representing the leftmost point on this Smith chart. We have different circles. First, let us consider different circles. These circles are giving these are called constant resistance circles. So on these circles, the resistance remains constant. So and there are portions of circles. Those portions of circles are constant reactance circles. On those portions, the reactance remains constant. On the diameter, which is passing through the left point and right point horizontal line, or which is along the real axis, the diameter along the real axis gives you real impedances or gives us only resistance. So that is the red line. The red line shows you real impedances or only resistance. At the center of this point, gamma is equal to 0. Because gamma is equal to 0, that is the center. Now we already have seen this is on the gamma plane. Center is gamma is equal to 0. Since it is on the gamma plane, origin must be gamma is equal to 0. So center is gamma is equal to 0. When gamma is equal to 0, then you know it is a matched circle. There is no reflection. Gamma is equal to 0 represents no reflection. So since there is no reflection, it is matched. So at the center point is the matching point. That represents a matched point. The leftmost point on this red line, it represents a short circuit point, because at that point gamma is equal to -1. Gamma is equal to -1, as you know, if gamma is equal to, if we have a short circuit, gamma reflection coefficient is equal to -1, because V minus by V plus will be equal to -1. V minus will be out of phase from V plus. So since they will be out of phase, therefore V minus by V plus is equal to -1. So we have the short circuit. Otherwise also you can say gamma is equal to Z minus Z0 by Z plus Z0. Z is, when you have a short circuit, Z is equal to 0. So 0 minus Z0 by 0 plus Z0, that is minus Z0 by Z0, that is -1. So gamma is equal to -1 represents a short circuit, which is on the left hand side. Right hand side is gamma is equal to +1. Gamma is equal to +1 represents the open circuit. This we have already discussed why it will be left hand will be short circuit, right hand will be open circuit from the resistance circle point of view. Now we can discuss it in terms of the reflection coefficient. Now if you are from the red line, if you are above the red line, that part is inductive, Xn is greater than 0. If you are below the red line, then those parts will be capacitive, their Xn is less than 0. Then the circle that passes through the matching point, and that circle, that resistance circle, for that resistance circle, Rn is equal to 1. Normalized Rn is normalized resistance. Normalized resistance is equal to 1 when it passes through that circle. So now our resistance is equal to the, if you take the complete resistance, normalized resistance is R by Z0. So R by Z0 is equal to 1. Rn is equal to R by Z0 is equal to 1. Therefore R is equal to Z0. So and this is the unit circle. This one is called the unit circle or constant unit resistance circle. This Rn is equal to 1 is called the unit resistance circle on the Smith chart. Now I will show you a Smith chart, real Smith chart. I hope I asked you yesterday to download the Smith chart. I hope you have downloaded the Smith chart. You have taken printouts of the Smith chart. The real Smith chart looks something like this. If you purchase a Smith chart is also available in the bookstores. You can purchase a Smith chart from the bookstore, or you can, nowadays it is available on the websites. So on Google, you Google for Smith chart, you will get a complete Smith chart. The Smith chart will look like this. Complete Smith chart will look like this. So in this Smith chart, you can see it is not visible, clearly visible. I will show you the portions of the Smith chart, the expanded portions of the Smith chart. If you have your Smith chart, you can see, take a close look at those Smith charts. So let me show you the portions. Now you can see this portion. This portion I have expanded. If you look at the Smith chart, look from the inner circle. There are actually 4 circles. You can see circle, outside circle is 1. So leaving that out, there are 4 circles. So from the outer circle, if you come inside, you have got the first circle, then the second, then the third, then the fourth. Now when you look at the 4th circle, below the 4th circle, it is written that try to look at this. What is written? It is written that inductive reactance or capacitive susceptance. You can see this is written clearly, inductive reactance or capacitive susceptance. So normalized inductive reactance or capacitive susceptance. That is on the innermost circle. So and the innermost circle values you can see 0.4, 0.6, 0.5, 0.3, all those values are given there. So that part, that circle, so when we ask you, when you are required to find out a capacitance or find out an inductance, this is for inductance. If you want to find out the inductance or the capacitive susceptance, you look at the outermost circle, this circle, outermost circle of the Smith chart. This is circle where it is written inductive component or the inductive reactance or the capacitive susceptance. Look at the value, whatever value you want. Look at that value. Then from that value, you follow the line, the circle corresponding to that value, the circle towards the open circuit point. So there will be a circle which is moving towards the open circuit point. So follow that value, so that along that circle, always the value will be capacitive and this value, sorry, inductive and whatever value you have found out. Suppose 0.4, so that will be always 0.4 along that circle. So this is one part. Then the next point is, look at the outermost circle. In the outermost circle, you can see that it is written wavelength towards generator and arrow mark is given. Arrow mark is in the clockwise direction, which means if you are moving in the clockwise direction along that circle, the outermost circle, then you are measuring the wavelength towards the generator, which means from the load you are moving towards the generator. When you are moving from the load towards the generator, the wavelength, the length of the transmission line, electrical length of the transmission line, that is given by this. So this is wavelength towards the generator. This will be the outermost circle. On the outer part, the wavelength value will be written. Remember one thing, that the Smith chart if you take a complete circle, one complete cycle on this Smith chart is equal to lambda by 2, half the wavelength. One complete cycle is half the wavelength. It starts from the short circuit point. So at the short circuit point it is 0. Then it moves gradually to the open circuit point where it will be 0.25. Then again it moves towards the short circuit point in the clockwise direction. When it reaches the short circuit point, it will be lambda by 2 or 0.5 lambda. So the complete the calibration will be from 0.1, 0.2, 0.3, etc. to 0.5 or 0.001. That way it will be calibrated the outside. So this is one point. So if we are moving from the load towards the generator, the length of the transmission line or the distance you travel from the load towards the generator is given in terms of wavelength, and that you can find on the Smith chart by moving in the clockwise direction. Next. Now you can see it is written wavelength towards load, which means you are moving from the generator towards load. In the previous case we saw moving from load towards generator. In this case, if we are moving from load from generator towards load, so wavelength towards load, that is given by the second circle. So in the circle, the outermost point is given for the wavelength towards the generator. Then the inner side, outer side is wavelength towards the generator. Inner side is the wavelength towards the load. So that will be in the counterclockwise direction. The first part is for the clockwise direction. Second part is in the counterclockwise direction. So if you are moving towards load, we have to move in the counterclockwise direction. If we are moving towards generator, we have to move in the clockwise direction. Remember these two. And since it will be, you can see it starts from 0.0, then goes on increasing in the counterclockwise direction. Below that, there you can see 180 degree, 170 degree, 160 degree. Okay, that we'll see in the next slide. Next slide. Here, as we saw in the first slide, the inductance. Here it is capacitance. So it is capacitance, normalized capacitance, or the normalized capacitive reactance, or the normalized inductive susceptance. So this is the innermost value. So you can see 0.6, 0.7, 0.8, etc. on the innermost circle, the numbers that you can see in the innermost circle, the innermost circle numbers, those represent the capacitive values. So you follow that line. If you follow that line, along that line, the value remains constant. The capacitive value remains constant if you follow that line. Okay, next. Then on the right hand side of the circle, you can see angle of reflection coefficient or angle of transmission coefficient. These two are on the right hand side. What is the angle? What do you mean by angle of reflection coefficient or angle of transmission coefficient? As we discussed, transmission coefficient or reflection coefficient, both are complex in nature. So they will have a magnitude and a phase. Phase is given by an angle. It will be of the form A or gamma. Gamma, let us take gamma. Gamma is the reflection coefficient. So gamma is equal to gamma L into e to the power minus j 2 beta t. Now gamma L is equal to absolute gamma, that is the absolute value of the magnitude, into exponential j phi. J phi is the angle. Phi is the angle. So that angle is given by this. So this is all about Smith chart on this chart. Then if you look at the bottom of the chart, there is a scale shown on the bottom of the chart. This scale, let me show you the expanded version of this scale. So there you can see there is a scale on the bottom of the chart. Expanded version of the source. If I expand that from the right hand side, left hand side, you can see written SWR. So the first line, upper part of the first line represents the SWR. So you have any point on the Smith chart. From that point, drop a vertical line onto these scales. The vertical line will meet these scales at different points. Wherever it meets the upper part of this line, that gives you the SWR. Okay. Then a return loss. So the next line gives you the return loss in dB. The lower part of return loss gives you the reflection coefficient gamma. Similarly, the transmission coefficient. So everything is given here. Okay. So this you can use. And this shows the resistive line. The center line or the resistive line that I showed you in the red color, that is shown here. The resistive line or the center line is shown here. Here we will take a break for maybe 2-3 minutes. Then we will come back and start. This is about the Smith chart to understand what are there in the Smith chart that we discussed. Then we will come back and discuss further.